Hi everyone, welcome to another in the series of talking point videos from Axial. I'm Dave Nicholson, one of the senior account managers, and I want to talk about virtualization in data centers today. Most of you will have virtualized your data centers to some degree, probably in the server field. You'll have done that to improve your application performance, provide sufficient compute resources to ensure your apps run fast and well. Problem seems to be in a lot of areas that the network is the bit that lets people down. So what I want to talk about is a little bit around how we can do things to help alleviate that little bottleneck. So I'm going to draw a little diagram now. This is a traditional three-layer architecture that most people have in the data center. So we have a bunch of access layer switches sitting down at this level, and these are all connected to your racks of servers down here, and then these will connect up to some sort of aggregation layer of switches here and eventually back to the core up here. And you have lots and lots of interconnects between all of these switches, using up lots and lots of ports and generally creating mayhem. And the difficulty seems to be, whilst you can apply compute resources to your applications and you virtualize this down here, you may have the database for an application sitting in a virtual machine in this rack. You may also have maybe a web front end part of the application sitting over here. You may have some other resources related to this app sitting over here. And they all need to communicate with each other in order to deliver the application out to your end users and customers. And the problem seems to be, if this thing needs to talk to this thing and this thing, traditionally, the route to doing that would be multiple hops up to this, maybe over here, maybe down here. This then has to talk back to this one, and this has to talk back to that one. And it may have to go in many, many different hops to bring things all together and deliver this application. And if you virtualize this, sometimes you don't actually know where these things are, because things like vMotion will take care of automatically moving things around to get the right resources. So today, something's here, something's here, something's here. Tomorrow they may be in different locations. Now, if you're an e-commerce company, delivering your application out to the great wide world is what makes you money. For example, Christmas time, more orders come in, you need to transact quickly, you need to process things. You may be doing a new product launch, in which case you might want to create some form of new network that brings marketing and engineering and sales together just for that product launch. The difficulty with this type of architecture is that whilst you can do all the compute stuff and spin all that up in seconds, this stuff can take days to reconfigure to generate that. So how do we get around it? There are a whole raft of ways of doing it, but today, just for something to think about, what if we started to virtualize these things here? Most of the traffic that we're talking about is running in this direction. It's running east and west between these resources that you're using to deliver your applications. So if that's where it runs, why do we send it north and south? Wouldn't it be cool if we could do this? Take an entire layer out completely. And that looks great. And we can now run all our traffic east to west, but how do we do things up here? Well, what we can create is something called a virtual chassis. Okay? Most people are very familiar with the idea of stacking switches to create a single IP address, something that's easy to manage. The advantage of a virtual chassis is you are able to simply interconnect these things, all of these access switches, at very high speed at the backplane. So you don't utilize lots of these ports to interconnect them. So this thing now has one IP address. It's very simple to manage, and it just looks like one big switch. So anything connected down here can be very quickly and very rapidly connected to anything else in this east-west direction. Now, if you need to bring things up into the core and out to the great wide world, that's easy. We now simply connect one end of the virtual chassis to each end of these switches here and link those together. and you create another virtual chassis here. So now I've only got two things to manage, which is pretty cool. And if I now need to get to the outside world, my routers would sit there, they're connected into the virtual chassis here. So I've now reduced my data center components to essentially three things: access layer virtual chassis, a core virtual chassis, and links to the outside world. I'm not going to draw all of the cross links and everything, you all know how that looks. What if I want to introduce security into this though? Very easy. We can actually do things like this. We can bring all our security centrally and run everything there. So we've now reduced our data center to essentially four components: access, core, security, and routers. Everything becomes much, much easier to manage. One of the beauties of using virtual chassis, as many of you will know, where you have the standard architectures, for redundancy you generally have to put in multiple links. Problem with that is you can get what are called bridge loops. There are protocols to resolve that, such as spanning tree. The spanning tree actually takes away some of the bandwidth that you're able to utilize, and it has lots of uplinks in a traditional architecture. So doing something like this, we can actually eliminate bridge loops, we can eliminate spanning tree, we can get back all of the bandwidth that you were losing using those protocols, and we've reduced the number of uplinks. Why is this good for you? Well, you've got fewer things to manage, you've got the bandwidth back, you've got operational benefit here, very simple to manage, you get better performance, you get better improvements in latency because of the high-speed links between the server racks in your east-west traffic path here, and you get instant resilience. So in a traditional architecture, if a link fails, you end up going through a reconvergence problem, and that can take several seconds, occasionally minutes. If you lose a link here, there is always, I'm going to put that one in because that one I missed, there is always a path for traffic to traverse. So let's take an example. That link there goes down, but I still need to communicate from this rack to this rack. I still have the ability to do it in 2 hops, not 4 or 5. So you get deterministic latency, you get better performance, you get fewer things to manage, lower cost. We've taken an entire layer of architecture out here. So we're saving on the power, we're saving on the rack space, we're saving on the cooling, we're saving on the maintenance. We're getting better performance, we're enabling people to deliver applications out into the market far faster, so their time to revenue is reduced. So this is just the first stage, this is just one example of how virtualization in data centers can help, going beyond the server virtualization. You start to do this, this is the first stage leading to a full fabric-based software-defined network, if that's the way you want to go. So if this has piqued your interest and you want to know more about some of the customers we've helped in this particular configuration, get in touch.